All right, let's talk about one of the most essential skills in programming, debugging. Today, we're going to learn how to stop thinking about it as a chore and start thinking like a detective, ready to solve even the most baffling coding mysteries. Let's dive in. You know the feeling, right? You've spent hours writing what you think is perfect code, you hit run, and it just doesn't work. Or even worse, it does something totally bizarre and unexpected. It's so frustrating. And yeah, it can really feel like the computer is just messing with you. But here's the secret. That feeling, that's part of the job. And if we just reframe it a little bit, it can actually be kind of fun. See, you're not just a programmer fighting with your code, you're a detective. And that bug, that's just your next big case. So let's get our detective gear on. Okay, first things first, any good detective has to know their adversary. For us, that means getting to know the different types of bugs you're going to run into out there in the wild. So our cases usually fall into one of three categories. First, you've got syntax errors. Think of these as simple typos or grammar mistakes in your code. Then you have runtime errors, which are the ones that pop up while the program is actually running, like, say, trying to divide by 0. And then there are the really tricky ones, logical errors. And here's the huge difference. Syntax and runtime errors, they're loud. They make a scene. The program crashes, and you usually get a nice error message that points you right to the problem. But logical errors? Oh, these guys are the silent assassins. The program runs just fine, no crashes, no errors, but the final result is just plain wrong. This, right here, is where the real detective work begins. Now, to solve these cases, every detective needs a toolkit. So let's open ours up and take a look at the gear we're working with, from the simplest tools to the most advanced.
First up, we've got the old reliable, the print statement. Honestly, think of this as your go-to for a quick interrogation. By just dropping a print statement into your code, you're basically pausing to ask your program, hey, what were you thinking at this exact moment? It's a surprisingly powerful way to figure out where your logic went off the rails.
But listen, don't just sprinkle print statements around randomly. You gotta be strategic, right? A good detective asks very specific questions. So use clear, formatted strings to label your output. Something like print f inside the loop user ID is 1,000 times more helpful than just print user ID. It lets you follow the evidence without getting buried in a sea of numbers. So what happens when a quick interrogation with a print statement just isn't cutting it? Well, that's when you bring out the forensics kit, the interactive debugger. Python's built-in debugger, PDB, is an amazing tool that lets you basically freeze time. You can pause your code right in the middle of its execution and just look around. You can examine the whole scene, variable by variable, line by line. Now, these are the commands you're going to use all the time. N for next just runs the current line and goes to the next one. But, and this is the pro tip, if that line calls another function, you'll want to use S for step to actually dive into that function and see what's happening inside. So N keeps you on the surface, S lets you go deeper. And at any point, you can just type P in a variable name to inspect its value. It's an incredible amount of control. Okay, for the really complex head-scratcher cases, you're going to want the full crime lab. And that's where IDE debuggers come in. These are these super powerful graphical tools that are built right into editors like VS Code or PyCharm, and they give you this amazing visual way to see exactly what your code is doing. Here's how it works. You just click in the margin of your code to set what's called a breakpoint. It's like a little stop sign. When your code hits that line, everything freezes. From there, you can step through your code one line at a time. And here's the magic. Your editor will literally show you a live list of all your variables, and you can watch them change in real time. You can see the entire call stack to see how you got there. It's like having a slow-motion, instant replay of the whole thing. It's probably the most efficient way to crack those tough cases. So, having the best tools is one thing, but a great detective also needs a method, a system. You need a plan of attack to go from total chaos and confusion to a clear solution. And this really is the key. Without a plan, you're just randomly changing things and hoping something works. People call it shotgun debugging. But with a system, you're the one in control of the investigation. And here is that plan. It's a simple 4-step method. Step 1, understand the problem. You have to know exactly what the code is supposed to do. Step 2, consistently reproduce the bug. Find a way to make the error happen on command. You can't fix a ghost. Step 3, isolate the source. Use all those tools we just talked about to narrow the problem down to a single line or function. And finally, step 4, test your fix. Make sure it actually solves the problem, and, just as important, that it didn't create a new one. So if you take one thing away, let it be this. Don't guess. Investigate. You have to resist that urge to just change code randomly and see what happens. Instead, form a hypothesis, a theory, about what's wrong, then use your tools to test that theory and just follow the evidence. Now, all this might seem like it's just about solving annoying little problems in our code, but debugging is a skill with unbelievably high stakes. Let's look at a famous real-world case where one little software bug had absolutely catastrophic results. Back on June 4th, 1996, the European Space Agency launched its shiny new rocket, the Ariane 5. This thing was a multi-billion-dollar project, a whole decade in the making. 37 seconds, that's it. Just 37 seconds after liftoff, the rocket veered way off course, and then it self-destructed in a massive fireball. And the cause wasn't a bad engine or a fuel leak. It was a single, uncaught software bug. So what on earth happened? Well, investigators traced it to one little piece of code that was reused from the older, slower Ariane 4 rocket. This code took a really big number, the rocket's horizontal velocity, and tried to stuff it into a much, much smaller variable. Imagine trying to pour a gallon of water into a tiny coffee cup. It's not going to fit, right? The data overflowed its container, which caused a fatal error, which shut down the entire guidance system. The lessons here are just huge. For us as developers, it's a massive reminder to always check your assumptions. That code worked perfectly fine on the Ariane 4 because it was a slower rocket. Nobody thought to retest that assumption for the much faster Ariane 5. So when you reuse code, don't just copy and paste it. Interrogate it. Ask, what was this code assuming? And is that still true here? That one question could save you. And that's really why this matters so much. Learning to debug well isn't just about squashing annoying errors. It's about building this deep, fundamental understanding of how your code actually works, from the inside out. And embracing that process is what makes you a stronger, more confident, and frankly, a much better developer. So the next time you hit a bug, try not to see it as a roadblock. See it as a mystery that's just waiting for you to solve it. It's your chance to put on that detective hat and start following the clues. Because every single bug isn't just a problem you have to fix, it's a lesson you get to learn. So the only question is, what's your next bug going to teach you?